All right, let's go back to part B. So part B is 2 to the n divided by 4n squared minus 1. All right, let's check the guidelines again, like the way we did in the previous case. So does the n term approach 0? Let's see. We have 2 to the n 4n squared minus 1. I have the feeling that this 2 to the n converges to infinity faster than the bottom because bottom is a quadratic. So I would give a shot of using the n term test, okay? So I'm going to look at the limits of the n term, okay? 2 to the n 4n squared minus 1, okay? And since this is infinity over infinity, right, I'm going to use the L'Hopital's rule. And you can check from the derivatives formula card that the derivative of 2 to the n is 2 to the n times ln2. And the derivative of the bottom is 8n only. This still goes to infinity over infinity. So one more time, I'm going to apply the L'Hopital's rule. So it's 2 to the n times ln2 is the derivative of 2 to the n, but I have another ln2 here. Okay, I carry that forward, and the bottom is 8. That's awesome because I have no n-related term in the bottom left, but still 2 to the n at the top. So that 2 to the n is going to let this go to infinity. Okay, so obviously this limit is not equal to 0 for sure, right? And we just nailed this in the first shot. That's awesome, right? So essentially this worked, and by the n term test, this is a divergent infinite series. Well, so let me just conclude here that divergent. Okay, the infinite series diverges. Would it be possible to use other items in the guideline? So is this a geometric series? No, you can check that. Is this a p series? No. Is this a telescoping series? No. Is this an alternating series? No, because I don't have any alternating part coming along here, right? No alternating part. So item number 2 is not applicable. So I'm going to put a cross mark here. Can the integral test, the root test, or the ratio test be applied? I think yes. At least I would give it a try because of the 2 to the n term here. All right, 2 to the n term, because that comes with the n power. This could be like a good application for you. Why don't you apply the ratio test maybe to this one? Not the root test, because this bottom term doesn't come with the n power, so you may get stuck in the calculation of the limit. But I would give a try of applying the ratio test to this problem. Okay, and can you compare the series to something known? Probably, or can you sort of like majorize or minorize this series by another one that you know the properties of? We must give a try, but on the top of my head I can't see that. But it's a good try. You can pause the video and then check the other tests. But n term test is, I think, the best for this case scenario.